Hello, my Algebra 2 students. We are talking about something a little different today. So still parabolas, but the idea of there's a third equation to be able to write a parabola and show how it forms from there. And that's called the locus definition. Now, locus, first thing that you should know, locus is just a set of points that fits any set of given conditions. So in this case, when it says the locus definition of a parabola, the parabola is the collection of all the points that are equidistant from a fixed point, known as a focus, and a fixed line. So it's all the points that are equidistant from the point, here would be our fixed point, and from the line, here's the line down here, all right? So the two names that you have to know, this is your focus here, this is called the directrix. And then that point right there is called the focus. So if you can find all the points that are equidistant from those two, they form a parabola. And so what you're seeing in the diagram here, so like point P1 is the same distance from F as it is from the line, and P2 is the same distance from F as it is from the line, and so on. And so I could put 3 little stripes and 3 little stripes, and it's not drawn perfectly to scale, but you get the idea. So it'll form a parabola here, all right? So how does this, determine an equation? Well, down here when it says understanding the locus definition of a parabola, draw several pairs of congruent segments. So you could draw your own here. So the most obvious one is if I was to draw a line straight down, this should be the midpoint so that this little segment is the same as that little segment. But I could draw it anywhere so that if I draw this in and then I draw that in, and now keep in mind you always have to draw it perpendicular. That's the shortest distance. Then this little length should be the same as that little length. And that's true no matter where you draw the point on the parabola. So like, let's say I draw the point way the heck up here. That means that that length here should be the same as this length if I drop it straight down. Right? So that's what you're looking at. So when it says, we can use this locus definition to create an equation using the vertex as HK. And it's saying you'll see the derivation of this in pre-calc or like showing like where this comes from in the future. Okay? But what you want to think of is how can we kind of build this in and then create the parabola? Well, you have to use the vertex point. So that's the vertex point right there. I'll just draw a little like arrow on down. All right. And so that's our HK. And so same thing with this guy right there. All right. And now the equation can vary depending on does the parabola open up or down, or does it open sideways? So when it opens up or down, that's what I would think of as a typical parabola, like a typical y equaling x squared. So in that case, when you see the equation, it's not going to look exactly like this, but the y is plain. The x has the square on it. So I'm going to write it like this, x minus h squared, and then equals 4p times y minus k. What this should look kind of familiar like is the circle equation that has the x minus h squared and then y minus k squared equals r squared. So the difference, only the x is being squared, and then also we have some other values introduced here. So this 4p multiplied by the y part, we'll explain that in just a moment. Same thing over here. The only difference is instead of it being y equals x squared, this is actually an example of an x equaling a y squared. So in this case, it's the y minus k part that's squared, and then we put 4p on the other side with the x minus h. So one side gets the squared, one side gets the 4p piece of it. And I'll explain what all those things mean as soon as we flip it on over here. All right. So when it says graphing parabolas with a focus directrix definition, okay, well, let's write down those two equations again. So we had the x minus h squared equals 4p times y minus k. And then I'm going to kind of break this up. Over here, I'm going to write the y minus k squared equals 4p x minus h. So little things to note. H always goes with the x, the y, and the k always go together. We said that when x is squared, this will open up. So here's some details I want you to add to your picture. Draw yourself a point and a line where this is our focus. Here's our directrix. Halfway between the focus and the directrix is where the vertex is going to go. And the vertex is always the HK. And then where the P value comes into this, P represents the distance from the focus to the vertex, as well as the distance from the vertex to the directrix. So what that means is on your cute little picture right here, this little distance right here from F to V, that's your P value. And then from V to the line, that's also your P value. We're going to plot a couple extra points on this parabola by going and creating basically a little line segment almost that's being parallel to the directrix. So that distance from P or from F all the way to the directrix is 2P, since it's P and then another P. So we're going to go to the left 2P. So you're just kind of eyeballing right now what that distance would be. But I'm going to mark it as 2P and plot a point. And then you're going to go to the right a distance of about 2P and plot another point. So the parabola is going to be made up of the vertex and those 2 points. And I want you to connect those dots. So that's going to be approximately what your parabola looks like. All right. So when we say down here, 2P equals the distance from, I want you to write the focus to the edge of the parabola. All right, because it's a lot to draw on there right now. So we won't draw that every time, but little details. All right, one last little thing to kind of take note of is that in this case, if the P value is positive, then the parabola opens up. If the P value is negative, then the parabola will open down, right? In terms of it being sideways, well, I'm not going to draw every single detail, but I want you to give yourself the basics again. In this case, for it to be sideways, the directrix needs to be a vertical line. And then the focus, put that over here, will be to the side of it. All right. So that means run yourself through those ideas again. The vertex is halfway between them. So here would be the vertex. So that little distance is P, that little distance is P. All right. In this case, that means the parabola opens sideways. And now the parabola always opens around the focus. So if I go up a distance of about 2P and then down a distance of about 2P, so I'm just kind of eyeballing on my paper here, that's what my parabola is going to look like. So you can kind of tell the further away these are, like the wider the parabola gets. But in this case, if P is positive, it means that the parabola will open to the right. If P is negative, it means the parabola will open to the left. So this is a lot of information to take in. Make sure you have it all written down, and then I kind of walk you through what's going on here. Feel free to pause the video anytime you need to. All right, bring it on down here. It says for each of these, identify the coordinates of the vertex, the focus, and the equation of the directrix. All right, so focus is a point, directrix is a line. Keep that in mind. Then graph the parabola on the set of axes. Okay, so when you look at this, I'm going to write the form beneath it. This is x minus h squared equals 4p times y minus k. All right, a couple of things to take away from this. Right off the bat, the vertex is the HK part of it. And so that's the 0, 0. That's the first thing. Easy. All right. From there, to figure out the focus or the directrix, you have to think about what way is this parabola going to open. So what I would look at is this is an x squared and then equals a y. So when it's an x squared, this means it's either going to open up or it's going to open down. Oh, good morning, Teddy. Hi. Hi. All right, so when it's x squared, that means it's either going to open up or down. So how we tell if it opens up or down, we said, is by the p value. So that's the last little thing here. That 4p is equal to 8. So if 4p equals 8, we can quick solve here. P comes out to be 2 and positive 2 in this case, which means it's going to open up, right? So since this was positive, it opens up. All right, why does that mean something to me? Well, come on over to the graph. If the vertex is at 0, 0, so there's my vertex, that means that the focus, excuse me, is literally going to be 2 units above that. So my focus, if I go 2 units above that, is right here at the point 0, 2. Right? Because there's that little P distance right there. The directrix will now be 2 units below that. So if I go 2 units below, I have to make it a line though. So it's a horizontal line in this case. So the equation of the directrix is going to be y equals, and it's crossing at -2. So I have all those little values here. All right, and then the last detail, it's 2p. Well, 2p would be equal to 2 times 2, or 4. So I'm going to come from the focus. So look at the definition up above. I'm going to go to the right 1, 2, 3, 4, and I'm going to go to the left 1, 2, 3, 4. So my parabola specifically, it doesn't go through the focus. It doesn't go through the directrix. Those two values kind of help anchor some other points. It goes through the vertex and then those 2 extra points at the end there. So when I draw my parabola, I'm going to do my best to make it a nice smooth curve that hits those points right there, right? And so keep in mind that that 4 right there, that means we plot 2 points, 4 units to the right and left of the focus. All right. So now you've seen one completely through, right? Let's see if we can try another one. So I'm going to slide on up. When I look at this next one, keep in mind, it's starting with y in front. So the k always goes with the y. So this is y minus k squared equals 4p and then x minus h, right? So when you go to pick out the vertex, remind yourself it's h and then k. So h and then k. So this is going to be -2 and then 0. And in case you were thinking, wait, I thought it was +2. The equation is x minus whatever h is. So you have to flip the sign when you're taking it out of there. All right. So go over to your graph. Go to -2, 0. There's your vertex. I'm going to mark that with V. From there, to figure out where everything else goes, I have to know, right, what way does this parabola open? So the fact that I'm seeing y being squared, this means that it's going to open either to the left or to the right. And so if you want to just write, open sideways, that's fine too, right? From how do I know which way? Well, solve for p. So if 4p equals 4, p comes out to be 1. Because it's a +1, that means that it opens to the right. Right? What that means is that the focus should be 1 unit to the right of the vertex. So go to the vertex, go 1 unit to the right, there should be my focus. Go 1 unit to the left, there's going to be where the directrix crosses. All right, that means my focus has the point -1, 0. And my directrix, remember it's a vertical line now, so it's an x equals line. So it's x equals -3. Right? You have to finish graphing it by thinking about, all right, well, what's 2p? Well, 2p would equal 2. So in this case, you're going to plot 2 more points, 2 units away from the focus. But in this case, you're going to go 2 units up and go 2 units down. So from the focus, go 2 units up and go 2 units down. And then that will kind of anchor the graph of your sideways parabola here. So it sounds geeky, but something that I always say, all right, is that the parabola basically hugs the focus. Oops. So I always think of like the F as standing for like your friend. You're hugging your friend, which I know right now we're not allowed to do, but remind yourself that that was a thing once, all right? So you're hugging around the focus. So it should always wrap like it's 2 little arms just wrapping right around the focus there. All right, let's see if we can do one or two more, and then we'll save one or two for class. So let's see here. For number 3, when you get to this, whoops, sorry, I'm a little off the screen there. It is super blurry today. Hopefully you guys can read that pretty well. All right, write the equation beneath it. X minus h squared equals 4p, and then y minus k. All right, h, k is your vertex. So everything is built off of the vertex. So my vertex then is the point 2, -3. So flip the sign. So +2, that's -3. Come over to your graph. Go over to 2, down 1, 2, 3. Mark it with V so you know it's your vertex there. All right. The next thing you'd want to look at, what is squared? Okay, well, the x is squared. So that means this thing either opens up or down. Right? And that's my notes for opens up or down. If that doesn't mean anything to you, then write the words out. Right? How do I know? Well, solve for p. So 4p is equal to -12. So when we divide, p comes out to be -3. All right, I've got a negative p-value, which means that it opens down. That's how I determine it. That means the focus is going to be below the vertex. So that 3, the negative is just sort of my direction. I'm going to go down 3 units and plot the focus. So go down 1, 2, 3. There's my focus. From there, 2p would be -6, or in this case, I just want to think about it as 6. So I'm going to go 6 to the left and 6 to the right of the focus. So if I go to the left, 1, 2, 3, 4, 5, 6, I land here. If I go to the right, I know I'm going to fall off the graph a little. That's okay. And now do my best to draw in the parabola. Right? The last part, we found them. We just didn't actually write it. So the focus, that is the point 2 and then -6. And then the directrix. Ooh, I did not graph that yet. Come back up. It's 3 units above it. So it would be the x-axis itself, but you can't just say x-axis. That's the line. Y equals 0. All right. So I'm thinking that might be a good place to stop. If you're feeling confident, maybe try number 4 on your own. Otherwise, we'll recap 4 and 5 in class. And if you have any questions, make sure to enter them now. Thanks.